Okay, guys, so this is the second video for the 5.1 chemical reactivity of metals. So what we want to do here is we're going to actually walk through this lab and see these reactions, see what's taking place, and then we'll be able to fill in our data table. So as you're watching this, if you need to pause the video, write down your observations in your data table, do that, okay? So let's start with, like it says in the procedures, we're going to start with just water, okay? We're going to see which elements react with water, okay? So here we're going to start with aluminum. Okay, I don't know if you can see that very well, but we got a little piece of aluminum down there. We're going to put some water in it. And if any of you guys have handled tinfoil before, probably not surprising, not really any reaction, right? It's not fizzing, not bubbling, anything like that. Okay, so that one, aluminum is unreactive. Okay, now I will say we used up all our lithium. We'll get to that one last. We don't have any lithium here. Okay, now let's go next to magnesium. Okay, let's see what it does. So here's magnesium down in the bottom. Okay, and again, not really anything. You can barely even see it kind of floating on the top there, right? So we're not really seeing any reaction with magnesium either. So magnesium and aluminum are unreactive with water. Okay, so let's go to sodium next. Okay, so we can kind of see there's a little chunk of sodium down there. Okay, so let's see what sodium does with water. Ooh. All right. So you probably can't see it, but there's a little tiny ball of that sodium floating on the top. We can see it's producing a lot of gas, fizzing around. The water's changing. And when I feel the bottom of this test tube, it's getting warm now. Okay. So that's a very vigorous, fast reaction. And now that piece of sodium is completely dissolved and broken down in the water. So we had a very strong reaction where we felt heat. We saw gases being produced. We heard fizzing, bubbling. Those are some of the things that we could record down in our data table. Okay. Now, fortunately, yes, we ran out of lithium yesterday, but lithium did the fairly similar thing. It's just a little bit slower. Right? It took a little bit longer. It wasn't quite as violent. So we saw fizzing, we saw bubbling. And so in those rankings, sodium would probably be a little bit more reactive than lithium. Okay. So now we've gone through those four. Okay, we've gotten sodium to react, we've gotten lithium to react, but still magnesium and aluminum are unreactive. Okay, so we are going to now move up to our weak acid, which is a 0.1 molar solution of hydrochloric acid, and we'll add it to the aluminum first again. Okay, so this is just a new piece of aluminum. Okay. Okay, and we can look. Really nothing going on again, right? It's just kind of floating there. No bubbling, there's no sounds. The acid is still very clear. Okay, so not a reaction. Okay, so let's go to our magnesium. And again, guys, if you need to pause the video to write down your results, make sure we're doing that. Okay, so again, there you can see our little bit of magnesium down at the bottom. Some acid in there. Okay. Ooh, okay. So now let's look really closely. We can see that it's starting to bubble. It's eating through that oxidative coating. Now it's really starting to fizz and move around. Okay. So our magnesium is reacting to the weak hydrochloric acid. Okay, let's see if you can see. Whoop. You can see those bubbles coming off of there. Okay, so that one would be bubbling, a little bit of fizzing, not anything too crazy. Okay, but we still haven't gotten aluminum to react. So I'm going to go ahead and add this in here. So now I'm going to move up to a stronger acidic solution. So we're going to 6 molar hydrochloric acid. Okay. Sometimes with this aluminum foil, it has a nice coating on it, which makes it very useful for us, but it takes a second to get going. But as it works through that coating, we'll start to see it really break down. So now let's talk about some of these things while we're waiting for this to go. one question that it asks in the analysis is, well, why don't we need to test sodium with hydrochloric acid, right? Why don't we put sodium in the strong or weak acid? Well, if we think about that progression, right, we're trying to rank them on reactivity. So if we know it reacts with water, we know it's going to react with hydrochloric acid. That's not going to give us any information, right? So it's kind of redundant to do that. That's why we didn't put those in there. Okay. So let's see. We can see it kind of looks like it's starting to fizz a little bit there. Once it gets through that coating, should see it take off. Okay. And then as we're thinking about this too, as we wait a little bit more, I want you to start locating these elements. Where are they on the periodic table? Okay, so we know that lithium and sodium are our most reactive elements, and then magnesium, and then aluminum. Okay, so we should start to see a very, there we go. Should start to see a nice trend with where are these most reactive metals. Now, when we draw our arrows to show reactivity, we want to make sure we pay close attention to lithium and sodium. And sodium was more reactive than lithium. So we got to keep that in mind as we draw those arrows. Okay, there we can see that it's taken off really good now, finally starting to break down in the strong acid. So yeah, so now use this information, answer the synthesis and the analysis as best as you can. If you have any questions, let me know. Thanks, bye.